Oh, yes. You have to make a jump score of 300 and above for you to stand a chance to study your dream course. Yes, it's possible. So that's why Leviton Tutorial is here to help you out in this. So you follow our tutorials, okay? From day 1 to day 80. So have 80 days. That's 2 months and okay before your jump exam, and you thank me later. Call your friends, tell your loved ones, okay, to join you. Are you a science student finding chemistry, physics, and the rest difficult? This is a time for you to succeed. So you follow our tutorial. So our tutorial actually goes in line with the syllable, because the syllable is just like a guide. It tells you what they want to set, the area they want you to concentrate on, not virtually everything in your textbook. There are places, there are areas they want you to concentrate on. So these are the areas we are working on. So we are following the syllable. So I will still drop the link for the syllable so that you can actually download the syllable and join us. Okay, let's look at it. This is actually the syllable for the 2024 UTME. So we'll be looking at the syllables. Okay, we're using it to study. It's just like a guide that will help us to pass our exams. Okay, so in this guide we'll be looking at them topic after topic. So gradually we'll move until we finish the topic. Okay, we still have the same thing in physics and other subjects. Let's go to the first. What they want us to achieve here is the topic is separation of mixtures and purification of chemical substances. So what they want us to know there is one is pure and impure substances. And what did they want us to study about pure and impure substances is they said I want us to distinguish between pure and impure substances. So that's our first step for today. So we're going to distinguish between pure and impure substances. Then later we'll come to boiling and melting points. Okay. Oh yes, like I told you guys, we said we'll be discussing it topic by topic. We'll have about 30 topics in chemistry. So we'll be taking it one after the other. Okay, so to meet our target is 60 days. 60 days, that's our target. Okay, so to be able to finish everything, chemistry, physics, and the rest 30 within the 60 days. So you having your 300 and above within the 60 days is our target. Okay, so whether you know chemistry or not, you just have to start with us. Okay, you just have to start, and gradually you move. Want to study nursing, want to study other vital courses, you just have to start. Okay, so it's something that is good at your leisure. You can just do it, and so on and so forth. You take it easily, and via the comment box you can ask me questions. I will answer you. So that is it. So let's start. So the topic here is separation of mixtures and purification of a chemical substance. Okay, pure and impure substances. Okay, so that is what we are looking at, pure and impure substances. So the objective under pure and impure substances is for us to distinguish between pure and impure substances. That's what the chapter 1 is all about. Okay, so that's the one part of the chapter 1, distinguishing between pure and impure substances. I think I have showed you guys in the scheme. That's the syllable they used. Okay, so you'll be going gradually. So pure substances examples are compound and elements. Okay, in nature, what I put in nature is the one that appear in nature. They are all called pure substances. Example is sugar, baking soda, gold, water, etc. There are many. Okay, so those ones are called in nature. Whether a compound or an element is called a pure substance. So pure substances are mainly compound and element that occur in nature, while impure substances are mainly mixtures mixtures. Okay, for example, impure substances include blood, urine, etc. These ones are mixtures. You can know that they're mixtures because blood has to do with cells and so on and so forth. Okay, the whatever the hemoglobin and so on and so forth. There are many mixtures inside the blood. So this is why they are called impure substances. So they are made of mixtures of many substances. That's what we mean by that. The impure substances, they cannot be separated into other substances by some physical method. What are the physical methods? For example, sieving, distillation, and so on and so forth. You cannot easily separate it, just like you want to actually separate something like a sugar. You're separating the component or the elements of sugar. Actually, it will take you time, or it will take you other methods, not just normal physical methods to separate those sugars. So that is it. So it cannot be separated by some physical methods. Okay, unlike the mixtures, something like you mix you mix two substances together. Okay, you can get your water, not like flood water, you can mix it. Flood water, you get it, you can separate it, you get your pure water, get your dirt and so on and so forth, residue. But in these ones, no. The components of pure substances, okay, are present in definite or fixed proportion. Yes, the components are indefinite or fixed proportion. Why have, for example, water, H2O, the one you know, it can only be H2O, nothing more, nothing less. If anything more than that, it might be a poison. Okay, so it can only be H2O. That's 2O, 2O. It cannot be H3O. It cannot be H4O. It cannot be HO. It must be H2O. So that is what they mean by that. So pure substances are present in a definite or fixed proportion. Number 3, pure substances have definite composition and definite physical and chemical properties. Yes, since they are uniform and they are homogeneous, so they have definite physical and chemical properties. The way you look at them is the same anywhere, any place. They are the same. Okay, they have the same chemical properties too. So they are homogeneous. Yes, they look alike. Okay, that is, their composition is uniform throughout the bulk. So throughout, they are the same. Properties used to measure the purity of a substance include something like boiling point of the substance. The boiling point actually determines the purity of a substance. How? It tells you that this substance is pure. Like water, you know that it's 100 degrees Celsius. That's the purity. The pure water can boil at 100 degrees Celsius. So anything higher than that, anything lower than that means that the water has been adulterated in the sense that they have added another substance to it. It is no longer pure. So that's why they can use a boiling point to measure, to determine or measure the purity of substances, and also the density of the substances also helps. You also use to measure the density of it. So density of water is 4,200. Okay, so in this now it can only be that, no more, no less. So that is it, or 4.2. Okay, then criteria for determining the purity of substance is constant melting and boiling point. Like I told you before, it must have a constant melting and boiling point. It must be constant. Okay, it must be constant. Then its density and refractive index. For those who have like something like diamond and so on and so forth, you can also use it to determine is a criteria for determining the purity of what of the substance. How to determine pure and impure substances using chromatography? How do you do that? Okay, method. A substance produces one spot on the chromatogram. It produces one spot on the chromatogram, while an impure substance or mixture produces two or more spots. Two or more spots. Okay, so the specific gravity of pure substances are usually greater than 1. No, for water is 1, is used to determine other specific gravity. So the specific gravity of pure substances are usually what? Slightly greater than 1. You can check it yourself. Sugar, you can check the specific gravity of sugar. Salt, you can check that of diamond, and so on and so forth. So you see what I'm talking about. So that is it. Okay, so after now, I'll give you some questions from the past question, then you answer yourself. If actually you follow the lecture, you'll be able to answer the questions. Okay, this is the questions from the past questions. Okay, I just selected them. That has to do with the topics. It said, the purity of a solid sample can best be determined by its A, boiling point, melting point, conductivity, solubility. So the answer is melting point because it's a solid. Number 2, A substance is said to be impure if its melting point range is wide, B. It dissolves in water with difficulty, C. It has a low melting point, then D. It is colored. Wow. The melting point, or yes, the melting point of pure substances are always high, not low. So for impure substances, they usually have low melting points. When we get to covalent bonds and electrovalent bonds, you understand that diamond, being a pure substance, is actually has a high, very high melting point. Okay, so electrovalent bonds, okay, most of the times, which contain most pure substances, have high melting point. Pure substances have high melting points, I can say. Then that is the reason why the answer has to be low melting point, because it's for what? Pure, impure substances. Number 3, a substance is said to be pure if it is colorless, it is soluble in water, its specific gravity is higher than 1, its melting point is sharp. Okay, from the options there, the option that is close to the answer is supposed to be the answer is B, because it is colorless. Colorless means that most pure substances are colorless. They have the attribute of being colorless. Diamond, water, uh, salt, okay, name them sugar, okay. Then 3, they have a specific gravity which is higher than 1, because water is the base for specific gravity, like I told you guys before. Okay, so we usually have higher gravity, gravity higher than 1.